Alright, so this is the last problem type in this section, and it's asking for the surface area of a parametric curve rotated about an axis. In this case, the axis is the x-axis. So pretty much these problems are just computational. You're given your two different formulas depending if it's rotated around x or y, and then you have your ds, which is the same expression used. You integrate that to find the the curve length. Sorry. So it's the same expression. You just have to throw in 2 pi and then a function either y or x in front of it, depending again x or y axis. So in this case, it is the x-axis, so we're going to be using this formula. For the most part, I like to start off just by doing the ds portion and then computing that and then going to the integral. So ds, so actually I'll start off dx dt squared, just to save a little room. It's 2 steps. So the derivative of x, so that's our x function in this problem, we're just taking the derivative, so 4t minus 1 over t squared, and that is squared. And then the dy dt is 4 over root t, and then we're squaring that as well, squared. So let's just add those together. So ds is equal to 4t minus 1/2 t squared, the quantity squared, plus, well, this one we can clean up right away, 16t, and all of that is root, and we have dt. Okay, so let's factor that out and see what happens. We have to be able to integrate this, so hopefully it's not this ugly by the end. So let's just start factoring. So 16t squared minus 8 over t minus 2ab, right? Plus 1 over t to the 4th plus 16 over t root dt. And then that is just equal to, we can combine like terms for the 16 over t and the negative 8 over t, leaving us with 8 over t. So at least this is a trinomial, and if you look at it, this can be written as the square of a term, so it would be, let's see here, 4t in the front, and at the end we would have to have a 1 over t to the squared, square rooted, and then that's just that just cancels, and we're just left with ds as 4t plus 1 over t squared dt. And that's our ds. Okay, awesome. Now that we've gotten that, we can go to the formula. So the formula S, alpha to beta, so these are just the values of t they give you. 1, 3, 2 pi, just a constant, and then x, oh, sorry, I'm using the wrong one. We're doing this one, right? Going about the x-axis, so we're actually using y, so it's 8 root t, and then our ds, which is 4t plus 1 over t squared dt. Just cut that off. Okay, so I'm going to start writing over here. Now that expression, let's clean it up a little bit. We can factor out 16 pi, okay, 1 to 3, and then from there let's actually factor that root t into the 2 other terms, leaving us with 4t to the 3/2 plus, well, let's see, root t over t squared is going to be t to the negative 3/2 dt. So just a little bit of cleaning up there, and now we're actually ready to integrate. This is just a polynomial, nothing too scary. So let's see, if we add 1 to 3/2, we get 5/2, so we pull out a 2/5, so we're at 8/5 t to the 5/2. And then let's see, is this negative or positive? Should be negative 2 to the t to the negative 1/2. And that's going from 1 to 3. Okay. And then from there, This is kind of ugly. I'm just going to rewrite that as 16 pi. Well, what I'm gonna do is factor out a 2 from both of the terms. So then we have 32 pi, and then we've got 4/5 t to the 5/2 minus 1 over root t. Just writing it like that. Okay, now we just plug in our 3. So 32 pi times 4/5, 3 to the 5th, well 3 to the 4th is 81, so root 243 for that, and then minus 1 over root 3, and then minus, and then this is f of b, we'd have 4/5 minus root 1, which is just 1. Okay. Do I want to clean this up a little bit more? Maybe we can try. 32 pi 4/5 root 243 minus root 3 over 3, and then we can combine those two into negative 1/5, so it becomes positive 1/5. And then if we go for a common denominator, hoping this works out, we'd have a common denominator of, let's see, 15. So 32 pi, so this one would be 12 root 243 minus 5 root 3 plus 3 over 15. And that should be the answer to this problem. So again, it's just pretty much computational. This is kind of the tricky part, right here, identifying that you can make it a perfect square and then kill the root, and that way you're actually able to integrate it. So yeah, there you go.